Question 4.5. For which values of k will the equation g of x equal to x plus k have two real roots? So two intersections, two non-imaginary real roots that are of the opposite signs though. So remember, g of x is our parabola, and that was, I keep forgetting, 2x plus 1 plus 1, and then we have equal to x plus k. And hopefully you recognize that this is an equation for a straight line. And that makes sense because we've actually been dealing with, that is horrendous, dealing with a straight line the entire problem. So what this question is asking is, where will these two equations be equal to one another, but have opposite signs for two roots? So where will these two equations have two intersections of opposite roots? So let's investigate in our graph. Now our graph might be a bit messy by now with color or tinkerings or rough work, but that's all right. We have y equal to x over here, and we have our hyperbolas over here. So currently they intersect here and here at S and B. Let's call them S and B. Now, as of now, they do have two roots, S and B, of opposite signs. Plus x, this would be a plus x, and in fact it would be plus root 3. And this would be a minus x, because we're in the negative x region of the axis. So they ask for what values, emphasis on values, emphasis on S, will this be the case throughout? Well, let's see. If we were to shift, now let's see if I can do this nicely. If we were to shift I'm trying to figure out how I can move the line. Oh well, if we were to shift this y equal to x line up, just like this, we would see that at some point over here, we would no longer have a positive root. We would always have a negative root over here, but at some point over here, when we cross that x-axis, while we carry on moving the y equal to x function upwards, we would skip over to the negative x region. And we don't want that, because that's not what the question is asking us. However, if we were to move the y equal to x function downwards, you can notice that it doesn't matter. If we were to keep moving this function down and down, we would always have a positive root and a negative root. And that's the key to the problem. So we can write here, k smaller than a value. And what will that value be? Well, as long as k does not move more than 3 units up, because look, we have an intersection with our hyperbola on the y-axis at 3, so as long as it doesn't move past 3, we are all good. So k must just always be smaller than 3, and then we will always have two roots that are real and are of opposite signs. And just to explain this notation here one more time, we are looking for a point on the graph where the g of x function equals an x plus k function, okay? And there have to be two intersections and they have to be of opposite signs. Fortunately for us, we already have a y equal to x graph on a function on our graph. So we can just look, how does this function move for values of k, which translate the graph up or down in a linear graph. Q, up, down, doesn't matter. For what values of k does this function equal this function at two intersections and are of opposite signs, where the sign has to do with the x-axis, because that is what roots are. They are points of intersection on the x-axis. And that is the problem solved.